Any questions about last session or last sessions in general? We covered word representations, and then we moved on to an application, which is about text classification. That was our first application. Any questions about these two topics?
A quick question about tokenization. Is there any, remember there was a semantic and syntactic kind of tests to see how effective it was? Is there any specific data set used for that, or just pull from any large corpus?
So your question is about tokenization.
Data sets for tokenization, yeah.
Yeah. So that depends. Usually you're going to start with the same corpus that you're going to use for training, and then you're going to tokenize that. But then these days, things have changed. You have a lot of data on the internet, basically come and crawl. People download that, and then they do the tokenization on that. And actually, the tokenization process, which is basically turning your text into integers, this is the idea of tokenization. We are going to spend a couple of sessions on that, a couple of papers, and try to cover more modern ways of doing it. But for now, you download the text, which is basically your training data. You tokenize it, basically extract the words. And the way that you're, at least in English, the way that you're going to extract your words is look at the spaces. You're going to extract the words. You're going to create a dictionary. You're going to create the histogram of your words appearing in your corpus. And you're going to get rid of the least frequent ones and just put them in the bucket of unknown. So this is the simplest way of doing tokenization for now. But then later on, we're going to see other ways of doing it. So did I answer your question?
Yeah, thank you.
Yeah, sure. But this is actually a very important question. And there is a literature on that particular topic. How do you turn your text into integers? And we're going to see that. So don't worry about it. For now, let's tokenize our words. Any other questions? Okay, perfect. So last session, we started with text classification. This is our first application for natural language processing. We covered the sentiment tree bank data, Stanford sentiment tree bank. The data had a tree structure. And then we said, how about our neural network having the same type of structure, having a tree structure? And then try to do semantic analysis. Basically classify between very negative, negative, neutral, positive, very positive, or in the case of having only two labels, is this a negative review? Is this a positive review? We didn't like the idea of creating a tree. So we said, how about coming up with an architecture that's able to work with raw sentences? And for that, we treated every single word that is appearing in a sentence as a pixel. And if you treat that as a pixel, a sentence is going to become a one-dimensional image. And now you can borrow ideas from CNNs to do sentence classification. Then as an alternative, we said, how about trying to borrow ideas from vector representations for words and apply them to our paragraphs, to our corpus? That's a good idea. This is a very flexible model. You have as many parameters as you have paragraphs or sentences. And because you have a lot of parameters, this is going to be as good a model as you can get. This is going to end up being extremely flexible. But there is a catch. We usually like to separate these two steps, training and inference. During training, we are allowed to take as much time as we want. But usually when it comes to inference, you want to be as fast as possible because you're putting your text classifier on a web page, and then millions of people are going to use your service. And you want their response time to be fast. And you want your users to get their results really fast. If you have an optimizer during the testing period or during the inference time, then that's actually one of the bottlenecks. And this is one of the shortcomings of this idea. It is doable. You can do it. It's a flexible model. In principle, it works. And it's actually doing really good in terms of your error rate. But the only catch is this optimization step. And this step, we usually want to work with models that are pre-trained You don't need to do any optimization during testing, like the previous idea that we had with convolutional neural networks, or even the first one having a recursive structure. The first one depends on the parser. We don't like it. So if we were to pick a winner among these three, perhaps the convolutional neural network is going to win here. It's able to work with raw data, raw sentences, and at the same time, it's giving you acceptable accuracy, and you don't need to do any optimization when it comes to inference, when you put your product, your model on a web page in production. Any questions so far? Because next I'm going to continue with CNNs and try to look at it from different perspectives. Okay, awesome. Let's start with the effective use of word order. This is actually an assignment for you to watch this video online. So I'm going to be really quick through this one. And then if there are any questions after my review, you can ask them. So in the meantime, please think of good questions to ask or any question. Okay, perfect. What do we want out of our classifier? First of all, when it comes to inference time, you want it to be able to work with sentences of variable length. Some sentences are shorter, some sentences are longer, and you want to design your architecture in such a way that this happens. So that's the first point, and that's the reason where you have these pooling layers. So if I want to emphasize one major contribution of this work is this pooling layer that you have. How do you do it? In the end, you want to work with vectors, and vectors are going to have a fixed size. And then you're going to do your classification. On top of that vector, you're going to put matrix vector multiplication, and then turn those numbers that are going to end up at the end, you're going to turn them into probabilities. And basically the idea is you want to turn a sentence, a sequence of words, into a vector. You're tabularizing your data. You're doing feature learning. The job of this pooling layer is to make sure that whatever the sentence length was originally, you are going to end up with a vector of the same size. How do you do it? You fix the number of pooling units that you like. And this is the actual dimension that you want to end up with. For instance, in this case, it's going to be 2. And then you're going to pool in a dynamic fashion. You're going to say, how many of my input do I have to pool together? And that you can dynamically compute. You look at the sentence length and you divide it by these, in this case, 2. And that's going to tell you that every 2 of these need to collapse into 1. So this is a pooling layer here. There is another layer of pooling over there. And then whatever is going to be your sentence length, you're adjusting your next layers to have a proper length. So all you need to specify for this pooling layer is how many, what is the length of the next sequence that you want to end up with in the next layer. So is this concept clear? It's as if I want to put you in a group. There are 14 students in the class. I want to end up with 5 groups in total. It means that I'm going to have to pool every 3 students together. I put them in a group. And then it could be the case that 2 students are going to end up in a group. So it's the same idea. In the end, you want to end up with 2 groups, and you're going to adjust the group size according to the sentence length. And this is usually done for testing during training, because you want to use the idea of mini batching. You usually cut your sentence. At some point, you're going to say that all of my sentences during training are 512 words. And the ones that are shorter, you're going to just mask them out. You're just going to put zeros. You're going to concatenate them. But when it comes to inference, these are the tricks that you're going to do. You're going to have a dynamic pooling layer. So is this idea clear? I need to hear a couple of yeses. Okay, perfect. The rest of it is convolutions. You have a document. Your document is a sequence of words. You're going to take those words, turn them into vectors. For instance, I is the 3rd word in your dictionary, and this is your dictionary. And going back to your question, how do you actually tokenize? This is how you tokenize for the time being. We are going to do smarter ways of tokenization. You create a vocabulary out of your corpus. You look at your sentences. You look at the first word in your sentence. That first word is the 3rd word in your dictionary. Therefore, you're going to put a 1 in the 3rd location. Love is the last word in your dictionary. So the last entry is a 1. It is the 1st word. And then you have two different ideas here. One is the bag of words CNN. The other one is the sequential CNN. And there is a trade-off here. Do you want to end up with a smaller model? If that's the case, maybe working with bag of words CNN is a better idea because you're going to end up with 5 parameters in total for this example. If you have more data and you have more memory, you can afford to have more parameters, and therefore you can write a more flexible model. And you're basically using CNNs here. This is more flexible. You have more parameters. And why am I saying it's more flexible? Because the order here, you're preserving the order. You're not putting all of your words, all of your, maybe a pair of word I love, and then love I with the bag of word CNN, they're going to collapse into the same vector. So you're losing some flexibility. You're losing some ordering. So it's a matter of trade-off between these two models. And it's actually a good exercise to understand CNNs. What are you doing? It's a one-dimensional image. These are your pixels. You take a window of 2 of these. That's your filter size for your CNN. That's going to give you the pair of I love. The other one is going to give you the pair of love it. That's another window. This is going to clearly convey the idea of parameter sharing. So the same parameters that you're going to multiply by the first window, you're going to use the same parameters to multiply by the second window. And this is why convolutions are parameter efficient. And then the rest of it is dot product of the window and that filter. And then that's going to give you your vectorized inputs for the next layer. And then you do pooling, and then you can report your error rates on IMDb classification task. That's a metric. There is also another good feature here. And what is that? You look at the predictions of your model on your sentences. Maybe a sentence went in, and then you are predicting that this is very negative, or this sentence was the most negative sentence in my corpus, because you can look at the scores. And then your neural network has 2 heads, a negative and a positive. So this output dimension is 2. You're looking at the negative scores. Your data goes in. The first sentence, you know the corresponding negativeness score. The second sentence goes in, you know the corresponding negativeness score. And therefore, you can sort your sentences according to how negative they are. And let's take a look at the top 5 negative examples, the top 5 most negative reviews. Now the question is, what is your neural network thinking? Why is it giving you negative? What is it seeing? And the way that you can do it is you take that input sequence, you look at the output of your neural network, and then you can take derivative of the output with respect to the inputs, with respect to every single word in your sentence. And then you can report the ones that have the highest absolute value, or they have the highest positive influence on being negative. And you come up with completely useless return policy. Maybe the return policy was completely useless. It won't even was the most important combination of words. And this is a way of actually looking inside your neural network. In the first part of our course, when it comes to images, we study these sorts of analysis, trying to visualize our neural network or our CNNs. This is exactly the same framework, but now you're applying it to sentences. So any questions about that? So was everything clear? Okay, cool. This is actually a very good paper giving us the details of CNNs. How do you actually deal with variable length sentences? This is actually one way of doing it. There are other ways of doing it as well. We are going to see them as the course progresses. And at the same time, it tries to look at the predictions of the model and try to make sense of the model. Why is the model giving you a very negative score for a sentence? You're sort of visualizing your words.